Okay, so we're going to do some fractional powers problems, and just in order to figure out how to do these, we're just going to do some examples and kind of talk about it along the way. So first off, we have 4 to the 1/2 power, and when you have a fractional power, this top number represents the exponent or the power, and the bottom number represents the root. So I think I'd have to write this to see this a little bit better. This would be the second root of 4 raised to the first power, and you can either put the first power in here or out here, whichever is more convenient for the current problem. So usually out there is better. And also because it's a square root, I wouldn't really have to put the 2, but we can put it there anyway. So the square root of 4 is the number that I would multiply by itself twice to get 4, and so that is 2. And then I would have to raise this to the first power, and so my answer is just 2. Okay, 4 to the 3/4. This one's similar. The number 4 has a 4th power, so that means it is the 4th root, and then raised to the 3rd power. For this one, the 4th root of 4, the number that multiplies by itself 4 times to get 4, is not a nice number. It's not something you can just come up with. So we can just rewrite it like that, and then we're kind of stuck. So you're just going to have to be left with that. Usually, when you're doing a problem like this, they give you something that actually works out, but this one, it's not. So be aware of that just in case that happens. Okay, -8 to the 2/3. The thirds, that's the 3rd root of -8. And then the 2 is the power, so that's going to be the 3rd root of -8 raised to the 2nd power. The 3rd root would be the thing that you multiply by itself 3 times to get -8, and that's going to be -2, because -2 times -2 times -2 equals -8. Okay, so that means that this part right here is -2, and then I'm going to go ahead and square that. And -2 squared is 4. So my answer is 4. And then I threw in 6 to the 0 here just as a little reminder. 6 to the 0 power is 1. Whenever you have anything raised to the 0 power, it's always 1. Okay, now we got down here kind of a bigger one to deal with. Let's take a look at 243 to the 3/5 power. This would be the 5th root of 243, then raised to the 3rd power. Okay, so I have to ask myself, what would I multiply 5 times by itself to be 243? And it's almost trial and error. Is it 2? You know, you ask yourself that. I know it's not 2 because I look at this number and it's not even, and if I multiply by 2 over and over again, I wouldn't get that number. But at least you can ask yourself this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. It's not nearly big enough either. Okay, what about 3? Could it be 3 to the 5th power equaling 243? Well, 3 times 3 is 9. And this 3 times 3 is also 9. 9 times 9 is 81. Times 3 is 243. So then we found it. So you kind of do it like that by trial and error to figure out what that answer would be. So this part right here, the 5th root of 243 is 3. And that has to then be raised to the 3rd power. And 3 to the 3rd power is 3 times 3 times 3, or 27. And there's some problems on fractional powers.